Alright, so moving on to question 5. As usual, what I suggest you do is try to solve this problem for yourself. I'm going to give you the answer, and if you're able to get the same answer that I give you, then you're all set on this type of question, and you're free to move on to the next video. If not, you can just come back on pause and work through it with me. So the answer to this question is D, 5.036 molal. Now for those of you who have tuned back in, I'm going to work through the question now, and you can work through it with me. So the question says, determine the molality of a 3.323 molar C6H12O6 aqueous solution. The solution density is 1.25 grams per centimeters cubed. Alright, so let's start by writing down our givens. Okay, determine the molality. So we already know what they're looking for. So what equals the molality? And let's just make sure we know what molality is. So molality is equal to the moles of solute over kilograms of solvent. Okay, so determine the molality of a 3.323 molar C6H12O6 solution. So 3.323 molar C6H12O6 aqueous solution. Now what is that telling us exactly? That is telling us that we have 3.323 moles of C6H12O6 per 1 liter of solution. Now we are also told from this that this is an aqueous solution. And what that means is that our solvent is water, H2O for water. So the solution density is 1.258 grams per centimeters cubed. Alright, so let's just separate this from the work we're going to do. Now, where do we begin? Well, let's start with what they're looking for. What is molality? Moles of solute versus kilograms of solvent. If we can find these two things, then we can solve. So, what are the moles of the solute? Well, we were actually given the moles of solute. We were told we have 3.323 moles for 1 liter. So we're all set there. They cut our work in half. Now we have to find kilograms of solvent. So the way we can do this is by saying that solution is equal to solute plus solvent. In order for this to be clear, I'm just going to draw it out. Here we have some kind of container filled with a liquid, and that liquid is our solvent. And then we have some type of thing being added, and that is our solute. And there you go. Alright, so we need to know kilograms of solute. So we can use this equation to say that kilograms of solution is equal to kilograms of solute plus kilograms of solvent. So let's see what we can find. Why don't we start with solute? Well, we were told we have this many moles of solute, and we can use the molar mass to find how many kilograms of solute we have. So we have 3.323 moles of C6H12O6, and for 1 mole, how many grams do we have? So this is the way I like to write it out in order to solve. We have C, H, and O. So we have CHO. We have 6 C's, 12 H's, and 6 O's. Now I'm going to multiply the number by its molar mass. So for C, we have a molar mass of 12. For H, we have a molar mass of 1. And for O, we have a molar mass of 16. So 6 times 12 is 72. 12 times 1 is 12. And 6 times 16 is 96. Let's just add those up. 72 times 12. Oh, no. Plus 72 plus 12. That would not be right. Plus 96 gives us 180 grams. So for 1 mole, we have 180 grams of C6H12O6. Let's cross out our moles, and we have grams. Let's get to kilograms because that's what we need for this equation. So there are 1,000 grams in 1 kilogram. Cross out our grams, and let's solve for kilograms. Right, so according to this, we have 0.598 kilograms of solute. And let's just plug that in. Alright, so kilograms of solvent and kilograms of solution. Well, we weren't given anything to solve for kilograms of solvent, and we know this is what we need to solve for because this is the piece of information that we're missing. So I'm just going to rewrite kilograms of solvent. So let's see if we can find kilograms of solution. Well, we know we have 1 liter of solution, so let's start there. SOLN for solution. Alright, so we were given a solution density. So we should find if we can convert liters to centimeters cubed. Well, 1 liter is equivalent to 1,000 milliliters. And cross out liters. 1 milliliter is equivalent to 1 centimeter cubed. And let's cross out our milliliters. And then we know that for 1 centimeter cubed, we have 1.258 grams. So let's cross out our centimeters cubed, and let's get to kilograms because that's what we need. 1,000 grams in 1 kilogram. Cross out our grams, and let's find how many kilograms of solution we have. So 1000 times 1.258 divided by 1000 gives us 1.258 kilograms of solution. And let's plug it in. Let's solve for kilograms of solvent. So we're going to have 1.258 minus 0.598 is equal to kilograms of solvent. .258 minus 0.598 gives us 0.66 kilograms is equal to kilograms of solvent. Alright, so now we have solved for kilograms of solvent and we can solve for our molality. I'm just going to rewrite what molality is. Molality is equal to moles of solute over kilograms of solvent. Just to clarify, moles of solute, our solute is C6H12O6. Kilograms of solvent, and our solvent is water, which we know because of this aqueous sign right here. Alright, so molality equals moles of C6H12O6, which we know is 3.323, over kilograms of H2O, which we know is 0.66. I should have reversed these. Hopefully you get what I mean. And let's solve. So we have 3.323 divided by 0.66 gives us 5.035 molal, which is our unit for molality, but you may also see a lowercase m. They're both the same thing. Alright, so this is basically equal to the answer we were given. It was just one number off, but that could just be a rounding error. I hope this video was helpful, and I will see you in the next video.